Good evening, dear students. So, in the last class, we have started with the chapter alcohol, phenols, and ethers, right? So, what all things we have discussed in the last class? So, what all things we have discussed? Yes. So, we have discussed the definitions. Okay, we have seen the general formula for alcohol, phenols, and ethers, right? Then we have seen the classification of alcohols and phenols, right? So first classification was based on the number of hydroxy group. Okay, so they are classified as mono, di, tri, or polyhydric depending upon how much which hydroxy groups are present. Okay, then we have seen the hybridization. Okay, that is the class of alcohols based on the where the OH group is attached, okay, to which hybridized carbon. So based on that also we have seen primary, secondary, and tertiary alcohols. Then we have discussed allylic alcohols, benzylic alcohols, right? Then we have discussed also about the vinylic alcohols. Then we have seen the nomenclature, how to name the alcohols as well as the phenols, right? So these things we have discussed, common name, how to give the common name, and the IUPAC nomenclature. Then we had started with what? Then we had started with the, then we have seen with the functional group also. So we have discussed the functional group, structure of the functional group with respect to the alcohols as well as the phenols, right? So how do we explain here the structure? Yes, how do we explain the structure of alcohols here? So in alcohols, you can see the oxygen, okay, the oxygen atom of the OH group, okay, it is attached to the what? To the carbon, and this carbon is what? It is sp3 hybridized, right? So how the sigma bond, the CO bond is formed? It is formed by the overlap, okay, overlap of the sp3 hybridized orbital of carbon with the sp3 hybridized orbital of oxygen. Okay, and the bond angle, as we know, it is slightly less than the tetrahedral angle. So the tetrahedral angle is what? 109 degree 28 minutes, right? But the angle here is less than that. Why? Because of the presence of the two unshared electron pairs on the oxygen. Okay, so because of that, there is a repulsion. So because of that, the angle is you have seen that it is less. Okay. Yes. So also, then we have discussed about what? The structure of your phenol. Okay, how we will explain the structure of phenols? So when you have seen the structure of phenol, that is the OH group is attached to the aromatic ring. Okay, so I'll just write down the structure here. So here the structure. So benzene ring is there. Okay, and it is attached to OH. So again, this oxygen has what? It has a lone pairs of electrons on the oxygen. Okay, the angle, it is 109 degree and the CO bond is 136 picometer. So in case of phenols, the OH is attached to the what type of carbon? It is sp2 hybridized carbon. Okay, of the aromatic ring. What is the bond length between the CO? It is 136 picometer, which is slightly less as compared to that of the your alcohol. Okay, what is the reason? The first reason is because of the sp2 hybridization of the carbon. It is slightly more electronegative. Okay, and this CO bond, it has some partial double bond character. Okay, so due to which the conjugation of this lone pair of electrons of oxygen with the benzene ring. Okay, so these are the structure of the functional group. Then we have discussed the preparation of alcohols. So preparations of alcohols, the first was from alkenes. Okay, that is acid catalyzed hydration. So hydration means we are adding the water in the presence of some acid. Okay, then we have seen hydroboration oxidation. So it is a oxidation reaction wherein we are adding a diborane, okay, B2H6. So subsequently, what is happening at each step? Hydrogen is replaced. Okay, it is hydrogen is replaced by the your this diborane. Okay, and at last we we react it with aqueous NaOH. Okay, and you get the what? You get the alcohol. Okay, so alkenes by treating it with diborane, it gives you trialkyl borane, which on further, okay, when you oxidize in the presence of aqueous sodium hydroxide will give you the alcohol. So as we know the addition reaction, so hydroboration reaction, okay, this reaction is going in the presence of hydrogen peroxide. So we have mentioned that whenever hydrogen peroxide we are using, that means what? The reaction will undergo which rule? Yes, when it is written hydrogen peroxide, when you have an unsymmetrical alkene, okay, how the addition takes place? It will take place to which rule? It will takes place by Markovnikov rule, right? So when there is a hydrogen peroxide written on that arrow, that means it will undergo what? It will undergo anti-Markovnikov rule, right? It will undergo what rule? It will undergo anti-Markovnikov rule. Anti-Markovnikov rule is the reverse of Markovnikov rule. Okay. Yes. So let us move further. So these two preparations we have seen. Then we have seen from carbonyl compounds, how do we get the alcohols, then reduction of carboxylic acid and esters. Okay, then from Grignard reagent also we have seen, right? Then we have seen the preparation of phenols. Okay, that is from haloarenes. It is called as Dove's process. Okay, so chlorobenzene, we are going to react it with NaOH. Okay, at 623 Kelvin and 300 atmospheric pressure, you are again going to get a sodium phenoxide. This sodium phenoxide, further when you treat it with HCl, you are going to get the phenol. Okay, so these are the, this is the Dove's process, DOW, Dove's process. Okay, it is called as the Duff's process. Then from benzene, sulfonic acid. So benzene, you're going to react it with oleum, H2S2O7. Okay, then you're going to get a sulfonic acid, benzene sulfonic acid. This benzene sulfonic acid, when you treat it with NaOH, you're going to get a sodium phenoxide. Further acidification, okay, you're going to get the phenol. So these are the steps, okay, to get the phenol. Next, we have seen cumene, very important reaction. So cumene, how we are going to get, so benzene, we are going to react it with your propene. I'm going to get isopropyl benzene. So this is the isopropyl benzene. This isopropyl benzene, when I do oxidation with air, what is a peroxy linkage is added, okay. And further, with acidification, I'm going to get phenol, and the byproduct obtained is acetone, which is very, very important. So byproduct also has to be mentioned. Next is phenol from diazonium salt. So how do you get phenol from diazonium salt? So aniline is the starting reactant that you have to react it with NaNO2, that is sodium nitrate plus HCl. So when sodium nitrate plus HCl reacts, you get nitrous acid. So nitrous acid is generated. This, what is cumene? Cumene, so benzene, so here it is. Okay, just let me complete this. So how this nitrous acid is generated? Nitrous acid is generated by reacting the NaNO2 with HCl. Okay, and the temperature has to be mentioned, that is 273 to 278 Kelvin. Okay, so then I'm going to get this benzene diazonium chloride. This, when I do hydrolysis, I'm going to get the phenol. Very, very important reaction. So let us see what is cumene. Okay, so how I'm going to get this cumene, students? So cumene, it is nothing but the isopropyl benzene. Okay, the name is isopropyl benzene. So how I'm going to get? So take the benzene. Okay, I'm going to react it with propene. Okay, I'm going to react it with propene. So, so what will happen here? So the reaction takes place. Okay, so here, so like this at the double bond, it will react. Okay, and you are going to get what? So I'm going to get this. What I'm going to get? Isopropyl benzene, which is called as what? Which is called as the propene. Okay, which is called as the propene. Okay, so this is called as propene. So or isopropyl benzene, or it is called as the cumene. Okay, it is called as cumene. So this is cumene. So benzene, when we react it with propene, I am going to get isopropyl benzene, which is called as cumene. So cumene, we are going to do further oxidation. Okay, we'll give you this hydroperoxide, cumene hydroperoxide. And further treatment with dilute acid will give you phenol. Okay. Yes. Next, we are going to see the physical properties. Okay, let us start with the physical properties. So alcohol, when you see the alcohol, so the structure of alcohol, it consists of two parts. One is the alkyl part, another is the hydroxyl part. Okay. Yes. So physical properties, we were discussing about the physical properties. So alcohol, they consist of two parts. Okay. So this is the functional group ROH. So this is one is the alkyl group, another is the OH group. Okay. Another is the OH group. Now, that is the hydroxyl. So the properties of alcohol, okay, it is mainly due to the hydroxyl group, okay, and the nature of the alkyl group will modify these properties, okay. So physical properties are mainly your boiling point, density, melting point, etc. So let us see how this boiling point will be affected, okay. So when you see the hydrocarbons, okay, and when you see this, so in alcohols, the boiling point of alcohols, it increases. Okay, as the number of carbon atom is increasing, and decreases with the increase in branching. So when you have a straight chain alcohols, the boiling point will be more. Okay, and when you have a branch chain, so that time what will happen to the boiling point? It goes on decreasing, because when you have straight chain, okay, the alcohols when they are in straight chain, then there is a increase in van der Waals forces. Okay, so there are some forces which are acting between the carbon and the, so you can see hydrogen and the your oxygen. Okay, so van der Waals forces are there. As the branching increases in the carbon chain, what will happen? There will be decrease in the this, okay, boiling point, because of the decrease in van der Waals forces. Okay, and the surface area also will be less. So here you can see that the alcohols here, they are forming the intermolecular hydrogen bonding. Intermolecular hydrogen bonding means what? When hydrogen will be attached or it links with a electronegative atom like oxygen, okay, nitrogen, it forms a bonding type of bonding called as intermolecular hydrogen bonding. Okay, now here what you can see, that the one cell, there are different molecules of alcohols, right? So what is happening between the different molecules? The hydrogen bonding is formed, so it is called as inter. Okay, when it is between different molecules, okay, between different two molecules of alcohol, inter. When it is between the same molecule, then it is called as inter. So what you have to remember in boiling point, that it increases with the increase in the number of carbon atom and decreases with the branching. Okay, then boiling point of alcohols are higher as compared to the hydrocarbons. Okay, and ethers of comparable molecular mass. What is the reason? Because in alcohols, what is present? It is there is a intermolecular hydrogen bonding. Okay, and when you see ethers, that is ROR dash. Okay, so it cannot form the intermolecular hydrogen bonding here, right? So the alcohols, they are highly, what you can say, they are having good high boiling point, okay, as compared to the hydrocarbons and molecular ethers, okay, which are of the same molecular mass. So here are the example, ethanol is there, this is a ether and this is a propane, that is a hydrocarbon. Okay, so when you see alcohol, your ether and propane, which is having almost the same, okay, the you can see the formula, but here you can see the molecule, what is that? Boiling point of ethanol is more as compared to your ether and this. Okay, why? Because there is what? There is a intermolecular hydrogen bonding is present in the alcohols. Yes. So next is solubility. What we say about solubility? So alcohols, they are soluble in water because they have the ability to form the hydrogen bonds. Okay, with the water molecules. Okay. So this is, you can see how it forms a hydrogen bonding, okay, with the water molecules, alcohol. So because they are, because of that, which are, they are soluble. Okay. Next is, so when you see the, so next we are going to see for, first the, so when you, let us see about phenols also, okay. So these are the colorless liquids or they are the crystalline solids, but become colored due to small oxidation with air, okay. So they are the colorless liquid, but when they are subjected to air, okay, how they react slowly with the air, so they become colored. Then this phenol is also called as carbolic acid. So phenol, the other name is carbolic acid, okay. Then because of the presence of the polar OH bond, phenols, they form intermolecular hydrogen bonding with other phenol molecules and with water. Okay, so as there is a OH group present, okay, on the phenols, what you can see, they form what type of bonding? They form the intermolecular hydrogen bonding, okay, with the phenol molecules and with the water. Then when we are seeing the physical properties of the ether, so the boiling point of ether is much lower than the corresponding alcohols, okay, because ethers, what is the structure of ether? It is ROR dash, okay. So these ethers, they do not form intermolecular hydrogen bonding. What they do not form? They do not form intermolecular hydrogen bonding, okay, because there is no, as compared to the alcohols, okay, ethers, they do not form intermolecular hydrogen bonding. And these ethers, they are slightly soluble in water. Okay, they are not completely soluble in water, but they are slightly soluble in water. Okay, so this is about the physical properties of alcohol, phenols, and ethers. Okay, so let us go next for the chemical properties or chemical reactions of alcohols and phenols. Okay, so chemical reactions of alcohols and phenols. So first is the reaction involving the cleavage of OH bond. So when we see the structure ROH, or when we see for a aromatic ring, okay, like this. So what type of linkage? So here you can see, so the bond can be broken between the CO bond, okay, and or the bond can be broken between the OH bond. Okay, so two type of chemical reaction can occur. So either the reaction can be by breaking the CO bond, or it can be between the OH bond. So first let us see the breaking of the bond, that is a cleavage, reactions involving the breakage or cleavage of OH bond, that is this way. Okay, so when the bond, that is, it is between the OH bond. Okay, the cleavage is taking place at OH bond. So first is reaction with metals. The first is reaction with metals. So alcohols and phenols, okay, they react with the active metals. So which are the active metals? Like your sodium, okay, then potassium, aluminium, and they give you corresponding alkoxide and phenoxide are formed. Okay, alkoxide and phenoxide are formed with the liberation of the hydrogen gas. So suppose ROH, okay, I'm going to react with sodium. So let me take it as sodium. So what I'm going to get? I'm going to get R, O, okay, OH bond is getting cut. So what I'm going to get? R, O, N, A. So this is minus, this is plus, right? This is minus and this is plus. So I'm going to get a sodium alkoxide. plus what I'm going to get, hydrogen gas will be liberated. Okay, and hydrogen gas will be liberated. So this is what, this is the reaction with metals. Understood? So this is for your alkoxide. So when alcohols react, they form alkoxide. So this is a sodium alkoxide. What is formed is a sodium alkoxide. Now I'll write for phenol. Okay, I'll write for phenol. So let me take the phenol. So this is the phenol. Okay, so how the reaction? So it will break here. So I'm going to react it with sodium. I'm going to react it with sodium. What I'm going to get here? I'm going to get ONA. Okay, so O minus Na plus. So this is what? It is sodium phenoxide. Okay, it is sodium phenoxide plus what is liberated, plus hydrogen gas is liberated. Okay, so these are the reactions with metal. I hope you have understood. Yes, so this is the chemical reaction where the cleavage of OH bond takes place. Yes, next. So next we are going to see the acidity of alcohols and phenols. So the acidity of alcohols and the phenols, okay, it depends on what? It depends on the polar nature of the OH bond. It depends on the nature of this OH bond, okay. Now in phenol, when we are seeing the phenol, the hydroxy group, okay, this is the hydroxy group. It is directly attached to what? It is directly attached to the sp2 hybridized carbon of the benzene ring, okay. And this and because of that, it acts as what? It acts as the OH group, acts as the electron withdrawing group. Okay, it acts as a electron withdrawing group. What do you mean by electron withdrawing group? It will withdraw the electron towards itself. It will attract the electron from the benzene ring towards itself. So OH group is the electron withdrawing group. So what is said that in the phenol, as the hydroxy group is directly attached to the sp2 hybridized carbon of the benzene ring, which acts as an electron withdrawing group, okay, then as compared to that of the your alcohols, what is happening? The OH group is attached to your alkyl group, okay, and this alkyl group is a electron donating group, okay, it is called as a electron donating group. So what will happen? Thus the ionization takes place in such a way that here the H plus is left and here the okay, it forms a phenoxide. Okay, phenoxide ion is formed. So this is the acidity. So when we are talking about the acidity, so respective alkoxide and phenoxide are formed. Okay, so how the acidity of alcohols or the phenols, it depends. It depends on the nature of the OH bond. Okay, nature of the OH bond and how this breakage takes place. It breaks heterolytically. What do you mean by heterolytically, students? When the break, now suppose hydrogen molecule is there. So if the molecule is broken, so how it will form? So each hydrogen will take one electron. So this is a homolytic cleavage. It's called as homolytic. Means what? Equally the electrons are distributed, okay, after the cleavage takes place. Now what do you mean by heterolytical or heterolytic? Heterolytic, suppose I take the example of HCl. Okay, now Cl is a highly electronegative group. So what it will do? It will tend to pull the electron towards itself. So as a result, what will happen? The chlorine will take the electron pair with that and hydrogen will left with the no electrons. Okay, it will become electron deficient. So this is heterolytic cleavage. So unequal distribution of electron takes place. So whenever we are discussing about acidity and of phenols and alcohols, it depends on the polar nature of OH bond. Okay. Yes. So next, let us see the esterification. Okay. Next is the esterification. So how these esters are formed? So esters, they are formed when alcohols and phenols, they react with carboxylic acid, acid chlorides and acid anhydride. Okay. So let us see how the esterification reaction takes place. So very, very important esterification reaction. So you can mark this important 2 marks question. Okay, so how the esters are formed? Suppose I take alcohol. So this is my alcohol. So alcohol will react with your acid. Okay, alcohol will react with your acid. So this is the acid in the presence of this is carboxylic acid. Okay, you take it as carboxylic acid. So we are taking one alcohol. Okay, we are taking one alcohol and we are taking a carboxylic acid in the presence of any concentrated acids. Okay, we are going to take any acid. Suppose I take concentrated H2SO4. Okay, I'll take concentrated H2SO4. So what I'm going to get, students, what I'm going to get? So I'm going to get one ether. Okay, I'm going to get one ester. Sorry, I'm going to get a ester. So O R, okay, plus I'm going to get water. Okay, so this will be eliminated as water. So I'll show you. I'll show you, just show you. Okay, so R O H. So let me rearrange it and write it properly. So it can be R dash, okay, H O O C. So now just see how I'm going to write here. Okay, so how the elimination takes place, just see here. So let me take another. So water is eliminated. Okay, and R, okay, so this is R dash, C double bond O, okay, and O, okay, and this is this R. So it is a ester. So esters are formed. So how esters are formed? First is when alcohols or phenols. So you can take alcohols or phenols. So depend. So in alcohols, R will be a alkyl group. In phenols, it will be a aromatic group. Okay, it will react with carboxylic acid in the presence of an acid, concentrated acid. You are going to get a ester and water. Okay. Then secondly, we are going to see the preparation of ester with acid chlorides. Okay, with acid chloride. So let me take, let me take a alcohol. So let me react it with the acid chloride. Okay, so this is the sorry, this is a acetic anhydride. So I'm taking acetic anhydride. Okay, I'm taking acidic anhydride. So I'm going to react it with in the presence of acid. So what I'm going to get? So I'm going to get one is the so like this one product, another will combine like this. Okay, so this will combine with this. So what I'm going to get? What I'm going to get? One is R C double bond O R. Okay, let me take this as R dash plus R C double bond O O H. Okay, so this is the answer what I am going to get. So R C double bond O O H. So like this. Understood? Is it clear? So let me write it once again. So R O H plus R C double bond O R C double bond O. So I can take this R dash and this I can take an R double dash. Okay, so how the reaction takes place? So I am going to get what? So first combination is with one will be your acid. Okay, so this is your acid. Okay, this is your acid and this is your ester. So acid is what? R double dash C double bond O OH. Okay, so this is a carboxylic acid. One byproduct is carboxylic acid. Another is your ester. Okay, another is your ester. Is it right? Yes. Did you understand? Okay. So next we are going to prepare the ester from acid. So let me take a alcohol plus acid chloride. Okay, acid chloride. So one this will be so let me take here as plus ROH. Okay, in the presence of H plus. In the presence of H plus. So what I'm going to get here? What I'm going to get? So let me rewrite it. So HOR. Okay. So let me rewrite it. So what I'm going to get here? HCl. Okay, one byproduct is HCl. HCl. Another is R dash C double bond O O R. Okay. So this is my ester. Understood? So three ways of preparing the ester. So these are the esterification reaction. Okay, so these are the esterification reaction. Okay. So in case of acid chloride, the reaction is carried out in the presence of base. Okay. We are taking a base. In other two, we have taken acid, but in case of the acid chloride, we are taking base, which is a pyridine. Okay, so that it can neutralize the HCl formed and shift the equilibrium to the right. So the product formed is HCl. So to shift the equilibrium to the right side, okay, to neutralize the reaction, we are making use of a base, that is a pyridine base. Okay, so this is a important reaction. Preparation of aspirin. They ask a question for 2 marks. How do you prepare aspirin? So aspirin is prepared by taking salicylic acid. So let me take a salicylic acid. So salicylic acid is carboxylic acid and OH. Okay. So how to prepare aspirin? So salicylic acid. Okay, react it with acetic anhydride CH3, C double bond O, CH3, C double bond O. So this is acetic anhydride in the presence of acid. Okay, so what it is going to form? What it is going to form? Your OH. Okay, so your OH group will be attached by one of this. Okay, CH3, CO. So what I'm going to get? So I'm going to get acetyl salicylic acid. So this is COOH and this is OCOCH3 plus CH3COH. Okay, so I'm going to get one ester. So this is ester and I'm going to get a carboxylic acid. So this reaction, it is following this reaction. Okay, so when alcohol reacts with a acetic anhydride, you are going to get what? Ester and carboxylic acid. Okay, as the products. So this is a very important esterification reaction. Is it clear? Any doubts up to here? Yes, any doubts? Okay. So let us go further. So next is the reaction which are involving the cleavage of CO bond. Okay, so we have seen the reactions where the cleavage is at the what OH bond. Now we are going to see the reactions where it involves the cleavage at your CO bond. Okay, in the alcohols. So reaction with hydrogen halide. So first reaction is hydrogen halide. So alcohols, okay, they react with hydrogen halide. Okay, and they are going to get alkyl halide. So RX. So this is alcohol. I'm going to react it with what? I'm going to react it with your what? HX. Okay, so what I'm going to get? Yes, what I'm going to get? So HX. Okay, so what it will combine? So I'm going to get water. Okay, so this is water as a byproduct, and I'm going to get HX. So that is your, okay, so I'm going to get HX. That is your alkyl halide. So alkyl halide. So, okay, so reaction with hydrogen halide. So alcohols react with hydrogen halide to form alkyl halide. First reaction. Second, very important reaction. Very, very important. Okay, 3 mark question. Dehydration. They'll ask you the mechanism here. Okay, they'll ask you the mechanism. Okay, so dehydration. So dehydration is what we have seen. Hydration. Hydration means addition of water. Dehydration means what, students? Removal of water. Okay. So alcohols, they undergo dehydration. Okay, and they form alkenes on treating with a protic acid. For example, concentrated H2SO4 or phosphoric acid or catalysts such as anhydrous zinc chloride or alumina. So you can use this. Okay, and you can do the dehydration reaction. So I've taken ethanol here. So this is a ethanol. What is ethanol? So CH3, CH2OH. Okay, so they have written the complete structure. So I have taken concentrated H2SO4 at a temperature of 180 degrees Celsius. Okay, you are taking more amount of acid. So what is happening? It forms a ethene. Okay, it forms ethene and water molecule is eliminated. So dehydration means water molecule is this. Okay, now this mechanism, which is very, very important, so you need to write as it is. Okay, so So 3 mark question. So you have to write as it is. You're not missing any step. So as it is, it has to be written. So they'll ask you write the mechanism or write the conversion of alcohol, that is ethanol to ethene by acid catalyzed dehydration. Okay. So you have to use these 3 steps. So first step is what? First step is the protonation. Okay, first step is the protonation. So let me write the structure. So CH3, okay, then CH2 and OH. Okay, so I'm going to protonate it. Okay, I'm going to protonate it. So what will happen? This lone pair of electrons on the oxygen will attack this H plus ion. So this is a fast reaction. And what I'm going to get? So I'm going to get what? Okay, so this is a protonated alcohol. So this is a protonated. Okay, then step. Okay, first step is protonation of alcohol, that is your ethanol. So what we are doing, lone pair of electrons, okay, they are going to attack the H plus ions, okay, and you're going to get a protonated alcohol. So you can see a positive charge on the oxygen. Okay, this charge has to be written properly. Okay, the charge has to be written properly. Second step is formation of carbocation. Okay, what do you mean by carbocation, students? Carbocation means the carbon with positive charge. Okay, so again the same step, same molecule I am going to write. Okay, the product which is formed there. So CH3, CH, okay, O, H, H. So this will have a positive charge. Okay, so what will undergo? It will undergo a slow reaction. Okay, what it will undergo? Slow reaction. So what will happen? There will be what? There will be removal of this O, that is your protonated water. So what will happen? So H, C, H, H, C, H, H, and you're going to get the charge on carbon plus water is eliminated. Okay, next step. Now we have to, what we have to see the, we have to balance the charge. Okay, we have to do the rearrangement. So next step is elimination of proton. Okay, we are going to eliminate the proton. So take the elimination of proton step. So again, we are going to write the same. So H, C, H, H, C, H, H plus. So what will happen? So this will undergo rearrangement. This will undergo rearrangement and you are going to get a alkene. Okay, I am going to get a alkene plus H plus is given out. So this is the mechanism of acid catalyzed dehydration of ethanol. So they'll ask you this compulsory question for 3 marks. Okay, this is a compulsory question for 3 marks asked from the chapter alcohol, phenols, and ether. That is the mechanism of acid catalyzed dehydration of ethanol. Okay, so conversion of ethanol to ethene using the acid catalyzed dehydration reaction. I hope it is clear. Yes. Is it clear, students? Any doubts up to here? Yes, any doubts up to here? Okay, fine. Okay. So next, we are going to see some of the important reaction, okay, where you can see the, so these are some of the important reactions for phenol. Okay, Rimmer-Timmer reaction. Okay, that is the Rimmer-Timmer reaction. So the Rimmer-Timmer reaction, it is a chemical reaction which is used for orthoformylation of phenols. Okay, so what we are doing here, we are preparing a salicylaldehyde. So we have seen previously that was salicylic acid. So that salicylic acid and here it is salicylaldehyde. So how we are going to do? conversion of phenol to salicylic, it is the name reaction, that is Rimmer-Timmer reaction. So they will tell you to explain the Rimmer-Timmer reaction for 2 marks. Okay. So you are going to explain is like this. So you're going to take phenol. Okay. You're going to react it with chloroform in the presence of aqueous NaOH. Okay. Chloroform in the presence of aqueous NaOH. So what it is going to get? You're going to get the intermediate product. Which intermediate product? So further, you're going to react it with NaOH. I'm going to get a intermediate again. Okay, further reacting with H plus ions, we are going to get the salicylic. So here you can see a phenoxide is formed. Okay, substituted phenoxide is formed. And this, what is happening when you protonate it, the Na plus ions will be replaced by your OH, H ions. Okay, Na ions will be replaced by the H plus. Okay. So these are the reactions. Then next is the coal-based reaction, very important name reaction, coal-based reaction. So coal-based process is a reaction that proceeds by heating sodium phenoxide with carbon dioxide. Okay, so again, so coal-based is also very, very important 2 marks question. So how you are going to explain it? So take a phenol, okay, react with sodium hydroxide. So what will happen? This H plus ions will be replaced by Na plus ions. Further reacted with carbon dioxide and H plus, you are going to get the salicylic acid. Okay, you are going to get the salicylic acid. So coal-based reaction. You are going to heat the sodium phenoxide with carbon dioxide. I'm going to get the 2-hydroxybenzoic acid, that is salicylic acid. So another name reaction, that is coal-based reaction. Next is the Friedel-Crafts reaction. Okay, so Friedel-Crafts reaction is an electrophilic aromatic reaction. Okay, so how the Friedel-Crafts reaction? So in Friedel-Crafts reaction, there is acylation and alkylation. The first one is the alkylation. We are going to see the alkylation. So we are going to, so what is our electrophile? It will be alkyl group. And in the second one, it is a acylation. So the electrophile is a acyl group. So this is the acyl group and this is the alkyl group. Okay. Now here, so what will happen? So we have a anisole. Okay. So and we have a anisole. So anisole. So that is you can see it is a ether. So anisole, what we are going to do? We are going to react it with the alkyl. Okay. It is undergoing Friedel-Crafts alkylation in the presence of anhydrous AlCl3. In the presence of anhydrous AlCl3. Okay. So this anhydrous AlCl3 and in the presence of CH2, that is carbon disulfide, I'm going to get what? I'm going to get 2-methoxytoluene. Okay, I'm going to get 2-methoxytoluene and 4-methoxytoluene. So whenever you have para position, so that will give you a major product. Okay, so because of the symmetry, it is highly, what you can say, it is major product. Then when you see acylation, so what is the electrophile here? What is the electrophile, students? In the alkylation, it is the alkyl group. Okay, CH3 plus. It is the alkyl group, which is the electrophile here. Okay. Now here acylation is CH3CO group. So it will go and attach to the ortho and para position. So again, para position is the major product. So these are the Friedel-Crafts acylation reactions. Okay. So we have seen, so what all reactions we have seen for phenols. So we have seen the Rimmer-Timmer reaction. Okay, we have seen the Rimmer-Timmer reaction. Then we have seen the coal-based reaction. We have seen the Friedel-Crafts reaction. Okay. So there are a few more reactions. So let us see those reactions also. Okay. So let us see some of the reactions, okay, where we were seeing the cleavage of CO bond. So a few more reactions are there, okay, and then we will stop. So we have seen the dehydration reaction. So dehydration means what? We are heating the alcohols. Okay, we are heating the alcohols. So after heating, what will happen? The water will be eliminated. Okay. So in the presence of concentrated H2SO4, or you can take orthophosphoric acid, and you can use the catalyst like ZnCl2 or alumina. Okay. Now, then there is one more important reaction, that is the Lucas reagent. Okay, there is an important reaction, that is Lucas test. So Lucas test, it is a test which is used to distinguish between primary, secondary and tertiary alcohols. Okay, and tertiary alcohols. So Lucas test, where it is used to distinguish between primary, secondary and tertiary alcohol. So very, very important. Mark this question as important for 3 marks. So the what is the Lucas reagent? Yes, what is a Lucas reagent? First question. So what is a Lucas reagent? Lucas reagent consists of concentrated HCl plus anhydrous ZnCl2. Okay. Concentrated HCl plus anhydrous ZnCl2. So that is your Lucas reagent. Okay. And how you can distinguish it? So when I have a primary alcohol. Okay. When I have a primary alcohol. Okay, so this is my, so let me, no need to write the equation also. You can just write in statement. So primary alcohols, okay, when they react with the, your Lucas reagent, okay, when they react with your Lucas reagent, what they form? They do not produce turbidity. Okay, they do not produce PPT. Okay, they do not produce PPT, or they do not produce turbidity. Okay, at room temperature. At room temperature. So this is the distinguishing test. So whenever you have primary alcohols, they will not give you any reaction. They will not give you any turbidity at room temperature. Then when you have secondary alcohols, okay, when you have secondary alcohols, when they react with Lucas reagent, okay, when they react with Lucas reagent, what it is going to form? It will give you PPT. Okay, it gives a PPT after 5 to 10 minutes. Okay, it will give you PPT after 5 to 10 minutes. So that is a distinguishing test for Lucas reagent. Then third is the tertiary alcohol. So if I have a tertiary alcohol, and if I add the Lucas reagent, okay, if I add the Lucas reagent, what it will give? It will give the PPT immediately. PPT is formed immediately. So these are the distinguishing tests. Okay. So it will give you immediate PPT. So now suppose, so how this will help us? So suppose I have an unknown alcohol. Okay, I have an unknown alcohol. Unknown. The alcohol is unknown. And what I want to find what type of alcohol it is, whether it is primary, secondary, or tertiary. So what I'll react it with Lucas reagent. And what is Lucas reagent? It is concentrated HCl plus anhydrous ZnCl2. Okay, so when I react it with this reagent, what it has done, it has given the PPT. Okay, it has given the PPT, but after 5 to 10 minutes. Okay, so from this, what you will come to know? What type of alcohol it is, students? Yes, what type of alcohol it is? From this, what you will come to know? Yes, what you will come to know? So what type of alcohol it is? So it is a, yes, what type of alcohol it is? Yes. It is a secondary alcohol. Okay, it is a secondary alcohol. So, based on what type of reaction is given, okay, you can identify what type of alcohol it is. So, this is a Lucas test. So, this is also a test, okay, Lucas test, which can use to be distinguishing the primary, secondary, and tertiary alcohols. Okay. Next reaction is reaction with phosphorus trihalides. Okay, so alcohols, when they reacted with phosphorus trihalides, so these are the, so reaction with phosphorus trihalides. Okay, so when so how the reactions takes place, just see. So phosphorus, when it reacts with your alcohol, when it reacts with your phosphorus trihalides, I am going to get phosphorus trihalides. I am going to get what? I am going to get alkyl halide. Okay, alkyl halide plus H3PO3. Okay, so suppose I have alcohol, so take ethyl alcohol, or the ethyl alcohol plus PCl3. Okay, PCl3. What I'm going to get? I'm going to get ethyl chloride plus H3PO3. Okay, I'm going to get ethyl chloride plus H3PO3. Okay, so this is the reaction. So we have seen what all reaction with the cleavage of CO bond. So what is happening here? The CO bond is broken. The bond is broken between the CO bond, right? So first we have seen the reaction with hydrogen halide. Then we have seen dehydration reaction. Then we have seen this Lucas reagent. Then we have seen the reaction with phosphorus trihalides. Okay. So phosphorus trihalides. Then we will see oxidation. Okay. Or the dehydrogenation. Or it is dehydrogenation. Now, what do you mean by oxidation, students? Oxidation means addition of oxygen. Okay. And dehydrogenation means removal of hydrogen. So what is the definition? If you remove hydrogen or when you add oxygen, it is nothing but oxidation, right? Removal of hydrogen and addition of addition of oxygen, it is reaction for your oxidation. So what we are doing, so oxidation of alcohol. So whenever the alcohols undergoes oxidation, what will happen? It involves the formation of your carbonyl group. Okay, so the bond is broken between the CH bond as well as the CO bond is broken. Okay, your OH bond is also broken and your this is also broken. So suppose this is your alcohol, right? So this is the alcohol representation. So what is happening here when the so this also is broken and this is also broken, and what it is going to get, you are going to get a ketone group. Okay, so it is going to form ketone. Okay, they are going to form the ketones. So this is the, so what happens here? So as it, so what you can see, there is a loss of hydrogen. Okay, from the alcohol. So this reaction, when there is a loss of hydrogen, we call it as dehydrogenation reaction. And we are using various oxidizing agent. So what all oxidizing agent we can use? We can use KMNO4. Okay, we can use KMNO4, we can use K2Cr2O7. Okay, there is sodium chromate. Okay, sodium dichromate. Then nitric acid we can use. Okay, then chromic acid we can use. So these are the different oxidizing agent. Okay, these are the different oxidizing agents which can be used. Okay, so suppose I have a primary alcohol. So let me take an example now. So suppose I have a primary alcohol. So let me take CH3 CH2OH. What is that? It is a ethyl alcohol. So ethyl alcohol, I am doing oxidation. Okay, in the presence of what? I am doing oxidation in the presence of K2Cr2O7, okay, and H2SO4. Okay, so what is going to happen? So it is CH3, C double bond OH. Okay, what is happening? So aldehyde is formed. This aldehyde, okay, first when I am what we are doing, oxygen is removed from here, right? So so here what is happening here? So first the alcohol is converted into aldehyde. Then again further, if I want to do oxidation, what is happening? This aldehyde, so first the alcohol, that is a ethyl alcohol, is converted into aldehyde, acetaldehyde. This acetaldehyde further on oxidation will be converted into a acid. Okay, that is your acetic acid. Okay, so what we are doing, we are adding up the oxygen and we are removing the hydrogen. Okay, dehydrogenation and oxidation takes place simultaneously. So what we are forming, we are forming the acetic acid. So these are the oxidation and dehydrogenation reaction where the cleavage of the OH bond takes place. Yes. Okay. So whenever we have the strong acids, now whenever we have the strong oxidizing agents like K2Cr2O7 and all, so what they do, sometimes they directly convert the alcohol into acetic acid. Okay, then that time aldehyde is not formed. Okay, so we can do this controlled reaction. So we can use this controlled reaction for the formation of aldehydes and your alcohol. So whichever is required. Now suppose I so that we have done with respect to primary. Okay. Now let me take the secondary alcohol. So which is the secondary alcohol? Yes. So let me take a propane tool. Okay. Let me take a propane tool. Suppose so CH3. Okay. Then CH3, OH. So this is a propane tool. So I am going to do oxidization. Okay. I am going to do oxidation with the help of bromic acid. So what is formed? Your what is happening here? Hydrogen is removed. Okay, hydrogen will be removed and you are going to get a ketone. Okay, you are going to get a acetone. I'm going to get a acetone. So secondary alcohols are converted into ketones. Okay, they are converted into ketones upon oxidation. And primary alcohols, what they have done, they are converted into aldehydes. Okay, again, if I do further, I'm going to convert it into carboxylic acid. So you have to remember this. Okay, you have to remember. So these are the oxidation reaction. Let us say next one with oxidation of tertiary alcohol. So if I take a tertiary alcohol, I hope you are paying your attention. Yes. Okay. So when I'm taking the tertiary alcohols, I'm going to do oxidation. So what will happen? Again, this oxidation will take place. So let me take any oxidizing agent like KMNO4. Okay. In the presence of H2SO4. So what I'm going to get? So what is the name of this? It is a tertiary. So 1, 2, 3, 4 carbons. So tertiary butyl alcohol. Okay, it is a tertiary group because three CH3 groups are attached to carbon. So it is a tertiary butyl alcohol. So what will form? It will give you a acetone. Okay, it will give you a acetone. Okay, again, so so now here, when you see the with respect to your primary and secondary, there were alpha hydrogen present. Okay, there were alpha hydrogen. Now here also CH3, CH2, OH. Okay, so alpha hydrogens are present here. Okay, so because of alpha hydrogen, the oxidation could undergo properly. But here, in case of the tertiary alcohol, there is no alpha hydrogen, right? So they cannot easily undergo oxidation. Okay, but in the presence of strong oxidizing agent like your KMNO4 and H2SO4 and at a very high temperature, then the breaking of this CC bond takes place. Okay, and it will give you a mixture of carboxylic acid and a alcohol. So first, so again further oxidation, what it will give you? It will give you carboxylic acid, okay, plus carbon dioxide plus water. Okay, so these are the reaction with tertiary alcohol. Is it clear? Okay, so this is a reaction with tertiary alcohol. Yes. So next we will see the dehydrogenation. Okay, let us see the dehydrogenation. So dehydrogenation means we are removing the hydrogen. Okay, now let us take a primary alcohol. So primary alcohol, so just now we have seen, so when I have a primary alcohol, okay, when it undergoes dehydrogenation in the presence of copper and 573 Kelvin, I am going to convert it into a aldehyde, okay, with the removal of hydrogen gas. So I can write the answer for this. So I have taken ethyl alcohol in the presence of copper and 573 Kelvin. What I am going to get? I am going to get a acid this, okay. So I'm going to get a acetaldehyde plus H2. Okay, acetaldehyde plus H2. So hydrogen molecule will be, it will escape out. So this is with respect to primary alcohol. Second is secondary alcohol. Suppose I have a secondary alcohol, so what will happen? Again, dehydrogenation. So there the dehydrogenation is carried out by using copper, okay, at 573 Kelvin. So again, what is going to come when you have a secondary alcohol? You are going to get a ketone with elimination of hydrogen gas. So if I give you an example of isopropyl alcohol, okay, isopropyl alcohol, in the presence of copper and 573 Kelvin, what I'm going to get? I'm going to get a ketone. Okay, I'm going to get a ketone plus H2. Then if I have a tertiary, suppose I have a tertiary alcohols undergo dehydrogenation in the presence of copper and 573 Kelvin. Yes, students, what I'm going to get? I'm going to get a alkene. Okay, I'm going to get a alkene. So tertiary alcohols, it will undergo dehydrogenation to give you what? They will give you alkenes. Okay, they are giving you alkenes. So these are the dehydrogenation reaction. Okay, so in the next class, we will see the reactions of phenols. Okay, few reactions we have seen like the Rimmer-Timmer reaction, Kolbe's reaction. Okay, so few reactions we have seen. We will see some more, and then we will see the ethers. Okay, then we will see the ethers. I hope you have understood what the things have been told. Okay, so we have completed the in today's class we have completed the chemical physical properties of alcohols and phenols, and we have started with the chemical reactions, okay, where the cleavage of CO bond takes and OH bond takes place. Okay, and we are going to we have seen few of the reactions of phenol. So the rest all the phenol reaction and about ether we are going to discuss it tomorrow's class. Okay, I hope you have understood whatever the things have been explained. Yes. Any doubts up to your? Yes. Okay. Fine. So we will continue the remaining part in tomorrow's class. Okay. Yes. Fine. So thank you. So I shall end this session here. So we'll meet in the next. Thank you, dear students.